Jackie Mason, I'm Fabrice. And
I'm Kevin.
so, the past 4 weeks we've been doing many interesting problems, but 3 weeks, sorry. But we chose our favorite two, and here they are.
Alright, we have a 9x9 checkerboard right here. And the challenge is to tessellate this entire checkerboard using this domino. Now, what's tessellating? Tessellating is able to cover this entire checkerboard using that domino without leaving any spaces or squares over there. Now, this is a 9x9 checkerboard, so there are 81 total squares, and therefore it's impossible to tessellate using domino, but it takes up 2, which is an even number. Now, you have here an 8x8 checkerboard, which is 64 squares. Now, this you can tessellate with domino since it's even. But what if we took out 2 opposite corner squares? Is it still able to tessellate? Remember, it's still even. It's 62 squares. Here, I'll give you a moment to try this out.
Just draw one on the board. Example. And you see we have 2 leftover squares here. And we figured out that this always happens. There's 2 squares left over which you can't tessellate with a domino. So after thinking about this for a while, we realized that a domino covers 1 shaded in square and 1 clear square. And by cutting out these 2 corners, which are both shaded in squares, you always have 2 clear squares left over, which aren't possible to tessellate with 1 domino. So that's how we proved that it was not possible.
Are there any questions? For the problem? All right.
Okay, so our problem is the 7 bridges of the coding sphere. So it's a basic problem where you've got 7 bridges and you want to cross them all by only going on them once. So you've got an upper shore, a lower shore, and an island, and a peninsula. And there's 2 bridges connecting the upper landmass and the island. 2 bridges connecting the lower landmass and the island. 1 connecting the island and the peninsula. And 2 bridges from the peninsula, from its landmass.
So, to make this simpler to think about and try to think this out, we can transfer this into a graph. So, we can make 1 vertice for each landmass. So, the 2 shores, the island and the peninsula, and then we draw edges to symbolize each of the bridges. So 2 from the island to the shore, 1 from the island to the peninsula, and 1 from the peninsula to each shore.
As explained by our previous group, each vertex has a degree, which is how many edges are coming away from it. So Ray is labeling the degree of each vertex. And as you can see on the table, as long as all, or well, at least 2 or more of each of the vertices have odd degrees, then you cannot have an Euler graph, which is the solution to the 7 bridges.
So it isn't possible. That's it.
Any questions?